Welcome back, fools. Today we're playing a new. I'm not really playing, but today I'm just gonna do some math because I'm bored. So I'm doing 8th grade things. Yeah, I'm just. Yeah. Anyways, I'm not there. So so right now I'm just doing math right now because I'm bored. So let's just explain everything while I'm bored. So what sign is -3 halves b 3.2b actually, times c over b times 0. Well, if there's a 0 in the problem, and it's not plus or minus 0, the answer for if this is an entire term. So if a term has a 0 in it, the answer is a 0. So this entire thing is a term. You see what I'm saying? And since it has a 0 in it, the answer is 0. Because there's no other term to add or subtract with, so it has to be 0. So find the real solutions of y cubed equals 27. So what times itself 3 times would equal 27? That would be 3. If it could also be -3 if this was 9 and this was y squared, but it's just 3, so because it's y cubed. And then negatives times 3 times, -3 times is always negative, but negative like an even amount of times, like 2 times, would always be positive. So that's just an explanation of why -3 wouldn't work here. So this is just 9/4. So let's just do this. This is really -9/4 times 9/4. You should be able to figure this out if you know what you're doing. It's 81 over 16. So the answer is 81 over 16. There you go. This is y over 2. If you don't know, I'll show you. So we have y to the 5th over y to the 3rd. So what you can really do is y times y times y. That's a 5. I don't know what I did. Y times y times. That's a 5 again. What am I doing? Y times y over y times y times. That's a 5 again. I'm bad. Y times y. So anything divided by itself would always equal 1. So this would equal 1, this would equal 1, this would equal 1. So we have and then pretend there's a times 1 at the end of everything. Because it wouldn't change anything, but it will make things make sense. So now we have y times 1, which is y squared, over 1. And that would equal y squared. So that's an explanation of how y times y to the 5th power divided by y cubed equals y to y squared. Next we have 63 over 75. So what you do here is just divide the numerator by the denominator, because it's really easy. 63, we can just immediately put a 0 here, bring up the decimal point. So 75 can go into 63 8 times. That would be 600, so we have 30 left over. This is chaos. So we have 300 left over. So that's the worst looking 300 I've ever seen in my life. So we'll just have a 300 here. And then now we have 75 can fit into 300 4 times. So the answer is 0.84. Without a calculator, which statement best describes this? Well, the square root of 74 is between 8 and 8.5 is between 8 and 9 guaranteed. So what is it actually? But 74 between 64 and 81. Because 81 is the same as 9 squared and 64 is the same as 8 squared. So 74, this is only 7 units away, while this is 10 units away. So the best answer would be between 8.5 and 9. So we have 2 to the 4th squared equals 2 to the blank, 2 to the n, basically. So how does this work? I know the answer is 2 to the 8th, but let's explain this. So you have 2 to the 4th, which is really the same as saying 2 to the 4th, which is really saying 2 times 2 times 2 times 2. And then you square that, which is now 2 times 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 2. And that's 2 8 times, which is 2 to the 8th. So that's an explanation of why that's 2 to the 8th. Oh, n equals 8. Sorry, there you go. I just didn't read the question, but hey, I got it correct because reasons. I don't know why, but yeah. Which of the following points resembles negative square root of 8? The square root of 8, no one can calculate this in their head unless we memorize the values of square root of 8. So we can do square root of 8 equals 2.82. And then since it's the negative version, it would have been, if it was negative inside on the 8, then it would be an imaginary number, which would be bad, but since it's on the outside of the radical sign, it's just a negative square root of 8. And since it's 2.82, it's k. Because since it's 2.82, and then you do the negative version, so you basically just flip-flop you just basically turn the number line backwards, or like split in half, and boom, it's k, because k is between negative 2.82, because it's a negative 2.82. There you go. What type of number is negative 5,614? It's an integer and rational. It's not a whole number because it has to be greater than 0 to be that. It has to be 0 or greater to be a whole number, and it can't have a decimal or place. So yeah. Without using a calculator, order the following expressions from least to greatest. There you go. If you guys have an issue with this, pi is 3.14, so 3 times 3.14 is greater than 9. And then 3.14 times 3.14 is bigger than just 3 times 3.14. So it's this. This is 7/9, but we could also do it this way. So I'm gonna do a trick. There's 2 ways to solve this thing. There's this way, where if anything after the decimal repeats over and over again, find the first digit of the find how many digits go to the right, and then that's how many 9s are in the decimal place. I mean that's how many 9s are on the denominator. And then, if you don't know what I'm saying, how many digits are to the right of the decimal, and then just put how many 9s are there. So if it was 0.72 repeating, it would be put a 99 there, because that's how many 9s. Because there's 2 to the left of the decimal. Since there's 2 to the right of the decimal, it would be 0.99. It would be put a 99 there, because we need how many digits to the right of the decimal, excluding zeros past the actual number, because there's no zeros in these numbers for some reason, but yeah. Ignore what I said there, I'm just thinking a little bit too technical right now. How many digits to the right of the decimal, that's how many 9s you put there. And then whatever digits are there, just that are repeating, just put the number up here. So we have 7/9. So that's why it's 7/9. If it was 0.72, for example, how many digits to the right of the decimal? 2, so it's 2 9s, or 99, and then it would be 72/99, because that's the number above it. But yeah, that's. So, and then the other way to solve this is just to multiply how many digits are repeating, which is 1, for example. So you multiply this number by 10. So now we have 7.7 repeating equals 10x. Yeah, I forgot to mention that this number is just x. Okay, this number is equal x. and then points, and then you do 0.7x equals x. 0.7. So now you can subtract. It would equal 7 over 9x. So divide by 9 on both sides. So now we have 7, 9 equals x. So this number, x, is 7/9. So yeah, there you go. Square root of 729. This one is really simple. If you know your cube roots well, it's 9. I could explain it though. So obviously it could also be an irrational number if this wasn't a perfect cube, but it is a perfect cube because you multiply 9 by 9 by 9, which is really 9 squared times 9, which is really 9 squared times 9, which you know 9 squared, I hope, it's 81. So now you do 81 times 9, which is 9, and then 72, so it's 729 equals, so this cube root of 729 is just 9. Any irrational number, if you do whatever to it, would always stay irrational unless if you're dividing that irrational number by the same irrational number. That's the only way to get it back. Or you could divide it, or you can multiply by 1 over that irrational number, but that's the same as dividing, so yeah. So pi divided by 2 would still be irrational, because pi is irrational. If it was pi divided by pi, then it would be 1, which is irrational, because you get the point. If it has an irrational value in it, it's always irrational unless if you divide the same irrational number. Divide that number by the same irrational number. So if it was pi divided by pi, it would equal 1. Just explaining. Select the equivalent expression. This would be 10 to the second times 7 to the fifth. And then you multiply, and then you raise the power to 5. So that's the same thing as 10 to the 10th times 7 to the 25th. There you go. So the answer is C. Should I explain this? Sure, why not? So it's basic. So what you're doing is multiplying by 10 times 10. That's 10 squared. So this value is that. And then you're multiplying 7, and then you're multiplying by 7 times 7 times 7 times 7 times 7, because that's the sum to the fifth. So this value is the same as this value. And then you're raising that power to 5. So this value, you raise the power to 5. So basically you're doing that 5 times. So now you're multiplying by this another 4 times. So you're multiplying this plus this multiplied by this 5 times by 5. So this is 100. But this is just 10 squared, and then you multiply it by another 10 squared, which is 10 to the fourth, and then you do that again, and then that will reach 10, and then you do that another 2.5 times. I mean 2 times. So yeah, this would be 10 to the fourth, and then it will get to 10 to the sixth, 10 to the eighth, and then it will reach 10 to the 10th, which is the 5th time. And then for 7, it's 7 to the 5th. It's 7 to the 5th. And then it would be 7 to the 10th, and then 7 to the 15th, and 7 to the 20th, and then 7 to the 25th. So that's an explanation. There you go. Without any equipment, you can see the stars that are 2.8 million light years away. By looking at a small telescope, you can see stars that are 3.12 billion light years away. So this number, in scientific notation, because this is written as scientific notation, this is roughly 3 times 10 to the 6th. While this number is roughly 3 times 10 to the 9th. So how many times as far can you see this? So that would be so basically you're dividing this number by that number. Well, it's not exactly that, but that's basically 3 billion divided by 3 million, which is 1,000, which is 1 times 10 to the third, or 10 to the third. Now you have this number. So rewrite the expression as a to the n when a to the fifth times a to the negative third, or negative cubed, but I just call it a to the negative third. So we have a to the fifth, which is a times a, that's a 5. I keep writing 5s for some reason. A times a times a times a. So you have a times a times a times a times a times 1 over a times 1 over a times 1 over a. Because a to the negative third is basically multiplying, because a to the negative first 3 times is just 1 over a. So a to the negative first equals 1 over a. So if a to the negative third is 1 over a times 1 over a times 1 over a, because you multiply it by 1 over a. Basically it's just, if you have a negative power, just put 1 over that power. So this number is also equal a to the fifth times 1 over a to the third. So like this. It's a to the fifth is times 1 to the a to the third, because if there's a negative exponent, a negative exponent, you just put a 1 over it and then delete the negative sign. So, or make it positive like that. So it's now 1 over a to the third, or positive third. But we're gonna write it as a times a times a times a times a times 1 over a times 1 over a times 1 over a, because that'll make it easier. So now you can multiply. A times 1 over a is 1. A times 1 over a is 1. A times 1 over a is 1. So now you're left with 2a, or a squared. 2 times a, or a squared. 2a times a, which is a squared. Next we have this number, which is x squared equals 36 over 49. So what times what equals 36 over 49? Well, if you know, x equals a number which I like to call n over t. So x squared would be n over t times n over t, which would equal 36 over 49. So what times what equals 36, and what times what equals 49? That would be 6 and 9. This is chaos. This is bad. Okay, we have 6 over 7, actually. So n has to be 6, and t has to be 7 to make 36 over 49. But does it have to be a must be? Well, no, because you can also make this negative, and negative 6 over 7 would still make times negative 6 over 7 would still equal positive 36 over 49. So it's a, because the square root of 36 is 6, and the square root of 49 is 7. So that would be 6 over 7, which is a. It can be b as well, because negative 6 sevenths times negative 6 sevenths is 36 over 49. But it can't be c, because that's 6 over 13, and it can't be d, because that's negative 6 over 13. So it has to be a or b, and it can't be anyone else. A table shown below gives the approximate number of approximate number of pieces of mail handled by the U.S. Postal Service for different years. How many more pieces of mail were handled by the U.S. Postal Service in 1995 than 1965? So how many more, which is subtraction? So you're basically doing 1995. This is also a function. Really? Because f of 1995 would be equal to 1.8 times 10 to the 11th. But obviously not everyone knows functions, so I'll just keep it. But I'll just keep it short. So I'll just keep it short. So we have 1995, which is 1.8 times 10 to the 11th, which is which is 18 with 10 zeros at the end. So we have 1 8 with 0 0 0 0 0 0 0 8 9 10. 18 with 10 zeros at the end. And then we have 1965, which is 72 with 9 zeros at the end. So 1, 2, 3. Oh, this is a mess. Did I even do this right? 1, 2. Okay, like this. Okay. 9 zeros at the end. So now you subtract. Which leads to 0 0 0 0 0 0 1 2 3 4 5 6 7 8 9. And then 10 minus 2 is 8, and then 17 minus 7 is 10. So the answer would be 1.08 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1.8 times 10 to the 11th pieces of mail. Since it's in scientific notation, it has to be this. But if it wasn't, it would be 180 billion. No, 1.08. It would be 108 billion. Almost messed up there, but I caught it. So the square root of 25 over 196 is just saying what times what equals 25 over 196. And that would be 5 over 14. It's the same thing as what I showed you earlier. It's 25 over 196. So we can say x, which equals n over t. And then so we have n over t times n over t equals 25 over 196. What n times n has to be 25, which means n has to be 5. And then t times t has to be 196. So t times t is 14. So t equals 14. So 14 times 14 is 196. 5 times 5 is 25. So now we have select the equivalent expression. So first we have, I would write this on paper, but I'm doing a video, so I have to write it here. So this is b to the 7th over 4 to the 5th, 4 over 5. And then you multiply it by -3. By the way, this expression by itself is already equal to b to the 7th times 4 to the -5. If you don't know how that works, I can show you right now. So first of all, b over 7 times 4 over 5. Let's just clear out all the room right now. 4 to the 5th, not 4 over 5, is the same as b to the 7th times 1 over 4 to the 5th. Which then you would multiply this together. So put it over 1, and then that would be b to the 7th over 4 to the 5th. So yeah, it has to. So b to the 7th over 4 to the 5th is equal to b to the 7th times 1 over 4 to the 5th. 1/4, which is the same thing as b to the 7th times 4 to the -5th. So yeah, that's a way. So, but for now we'll just keep it like this. You have to remember that for later though. So b to the 7th times to to the negative third is b to the negative 21st over 4 to the negative 15th. So now you're like, we don't see that. We see b to the negative 21st times 4 to the negative 15th, but it's divided by. So what you do here. So now, what you do, get rid of everything. I want to erase this, please. There we go. So now what do you do? So we have, we'll write this in blue. So now we have b to the negative 21st over 4 to the negative 15th. But remember what I said. This is really the same thing as multiplying. This is really the same thing as multiplying b to the 7th times 4 to the negative 5th to the negative 3rd. Remember what I said that? Well, if this was a negative 5, this would then be positive. So it's 4 to the positive 15th times b to the 7th, negative 21st. And that is exactly the same as this. Remember? Remember when I said that? b to the negative 21st times divided by 4 over negative 15 is the same thing as b to the negative 21st times 4 to the 15th. That these two equations, I'll write this in turquoise. These two equations are the exact same. So now, what can you do with that information? So now you can now do this. So b to the negative 21st is the same thing as 1 over b to the 21st. And then you multiply that, by 4 to the 15th. So now you can put that over 1, and that would be 4 to the 15th over b to the negative 21st. B to the 21st, which is one of the answer choices. If you don't understand how I got there, you can either rewatch it, or I can do a really quick explanation. So first, we have b to the 7th. This takes forever. Yoink. Doggone. Okay. First, a really quick explanation. b to the 7th to the negative 3rd is b to the negative 21st over 4 to the negative 15th, which is the same thing as b to the negative 21st times 4 to the 15th. 4 to the 15th. And then you multiply those together. So we have b to the negative 21st times 4 to the 15th. Same thing as 1 over b to the 21st times 4 to the 15th over 1. And then that would be the same thing. If once you multiply this together, it would be b to the 15th, 4 to the 15th over b to the 21st. Express your answer in scientific notation. This is the we have 3,600 minus which is minus 63 with the 0 at the end. Think about it. 6.3. Move once, move twice. Boom, it's 630. So the answer is 1,970, or 1.97 times 10 to the 3rd. I think. If I'm not wrong, this should, if you do the math, that'd be 7. 35 minus 6 is 29. I made a mistake. Ignore what I did. There you go. And also, it's not a plus sign. What am I doing? It's a multiplication sign. There you go. There you go. Answer is correct. And now you have the square root of 17.8 squared. Well, if you know anything about squares and square roots, they cancel each other out, so now we're left with 17.8. Then the final equation is x to the negative 6th equals what? Remember when I said any negative power is the same thing as put 1 over and then turn the negative into a positive? Well, it's just 1 over x to 6 and 6th. So, you saw that 96% there? It's up to 100, and I leveled up. So yeah, that's basically what you do for Unit 1, numbers and operations. So yeah, that'll be it for the mathematical video. We'll see you next time. Goodbye.